Let's talk now about using frameworks and design patterns that are provided with the Cocoa framework that you use to develop apps for the iPhone. When people talk about object-oriented programming, they tend to talk about two things. The first is all that cool encapsulation and polymorphism stuff that I talked about in another video, all of which make it easy to modify programs. Then developers talk about reuse, that you can create reusable objects that save time and money. When you enhance or extend your program, what you're doing is reusing the existing code to create essentially a new program. The best models for reusability are found in the frameworks that you use to develop apps for the iPhone and iPad. You reuse the frameworks by adding your own app functionality to a framework that already includes the code for stuff like displaying windows and controls and menus. You see, it takes more than a language to write a program. It takes a village. So who lives in the Objective-C village? Most objective-oriented development environments consist of several parts: an object-oriented programming language, which is Objective-C, a runtime system, which is part of Objective-C on the Mac, a framework or library of objects and functions, and a suite of development tools. That would be Xcode. The framework comes with your SDK. One of the defining features of Objective-C is its runtime system, which is linked to your program. It acts as a kind of operating system, like the Mac's OS X or the iPhone's iOS, but it acts like one for an individual Objective-C program. This runtime system is responsible for making some of the very powerful features of Objective-C work. The set of frameworks that you use is called Cocoa. It is what the industry refers to as an application environment, because it includes not only a suite of software libraries to help you create code, but also an integrated development environment. That would be Xcode. Cocoa, which is just like the chocolate, came along with Objective-C when Apple acquired Next in 1996, and back then it was called NextStep. Cocoa provides all the stuff you need to make your application. It provides support for Windows and other user elements, as well as many of the other things that are needed in most applications. When you use Cocoa, developing your application is way easier because all you need to do is add the app's specific functionality, the content as well as the controls and views that enable the user to access and use that content. And you add that functionality to the Cocoa set of frameworks. The framework offers common code that provides generic functionality. iOS provides a set of frameworks for incorporating technologies, services, and features. For example, the UIKit framework gives you event handling support, drawing support, windows, views, and controls that you use in your app. Here you see that we have imported UIKit directly into our My World App Delegate header file. The frameworks are distinct bodies of code that actually implement your app's generic functionality. This is especially true of UIKit, which is the heart of the user interface. The fact that UIKit is imported into the header file means all of UIKit is available to this app. A framework is designed to easily integrate your code that runs your game or delivers the information your user wants. Frameworks are similar to software libraries, but they also implement a program's flow of control, unlike a software library whose components are arranged by the programmer into a flow of control. This means that instead of the programmer deciding the order in which things should happen, such as which messages are sent to which objects and in what order when an application launches or when a user touches a button on the screen, that order is part of the framework. And so when you use a framework, you provide your app with a ready-made set of basic functions. You've told your app, here's how to act. With the framework in place, all you need to do is add the specific functionality that you want in the app, the content as well as the controls and views. The frameworks in iOS provide pretty complex functionality, such as launching the app and displaying a window on the screen, or displaying controls on the screen and responding to a user action, such as tapping a button or scrolling a view, or accessing sites on the internet, not just through a browser, but from within your own program, or managing user preferences, playing sounds and movies, and the list goes on and on. Some developers talk in terms of using a framework, but in fact, your code doesn't use the framework as much as the framework uses your code. Your code provides the functions that the framework accesses. The framework needs your code to become an app that does something other than start up, display a blank window, and then end. This perspective makes figuring out how to work with a framework much easier. Of course, all that complexity and convenience comes at a cost. It can be really difficult to get your head around the whole thing and know exactly where and how to add your app's functionality to the functionality that the framework supplies. And that's where design patterns come in. Understanding the design patterns behind the frameworks gives you a way of thinking about a framework, especially UIKit, that doesn't make your head explode. So let's talk for a minute about these design patterns. The COCO framework is designed around certain programming paradigms, known as design patterns, that are commonly used to give you a consistent way of getting a particular task done. So remember, when it comes to iPhone app development, the UIKit framework does a lot of the heavy lifting for you. And that's all well and good, but it's a little more complicated than that. The framework is designed around these programming paradigms. The design pattern is a model that your own code must be consistent with. Getting a handle on the basic design patterns that the framework uses and expects, this helps you develop an app that makes the best use of the framework. This means the least amount of work in the shortest amount of time. The design patterns can also help you understand not only how to structure your code, but also how the framework itself is structured. These are the basic design patterns: model view controller, delegation, block objects, target action, and managed memory. Of these, the model view controller design pattern is the key to understanding how an iPhone app works. I'm going to be talking about the first four, as I already mentioned the managed memory model in another video. Now remember, all the iOS frameworks are object-oriented. The easiest way to understand what that really means is to think about a team. The work that needs to get done is divided up and assigned to individual team members, or objects. Every team member has a job and works with other team members to get things done. What's more, a good team doesn't butt in on what other members are doing, much like the way an object in object-oriented programming spends its time taking care of business and not caring what the object in the virtual cubicle next door is doing. Object-oriented programming was originally developed to make code more maintainable, reusable, extensible, and understandable by tucking all the functionality behind well-defined interfaces. The actual details of how something works, as well as its data, are hidden, which makes modifying and extending the application that much easier. But still, exactly how do you decide on the objects and what each one does? Sometimes the answer to that question is pretty easy. Just use the real world as a model. But when it comes to a generic program structure, how do you decide what objects to use? This may not be so obvious. The model view controller design pattern implements the kind of object encapsulation that reduces the impact of changes to an app. This design pattern is not unique to COCO. A version of it has been in use since the early days of Smalltalk, the programming language that Objective-C bases its extensions on. The MVC design pattern goes back a long way, and the fact that it is still being used tells you something about its value. So, Model View Controller, or MVC, divides your application into three groups of objects and encourages you to limit the interaction between those objects and to others in its own group as much as possible. It creates, in effect, a world for the application, placing objects in one of three categories: model, view, and controller. It specifies roles and responsibilities for all three kinds of objects, as well as the way they're supposed to interact with each other. The MVC pattern is a well-established way to group app functions into objects. It creates, in effect, a miniature universe populated with these three objects. To show you how this works, imagine for a minute a big, beautiful 60-inch flat-screen TV. Model objects together comprise the content engine of your app. They contain the app's data and logic, making your app more than just a pretty face. This is where most of your objects are. You can think of the model, which may be one object or several, as a particular television program. And frankly, that television program does not give a hoot about what TV set it's being shown on. In fact, the model shouldn't care. Even though it owns its data, it should have no connection to the user interface and should be blissfully ignorant about what is being done with its data. Model objects are very generous with what they can do and are happy to share what they know with the rest of your application. But not only do they not care about what other objects use them, or what these objects do with the information they provide, but being good objects, they also really don't want to know. Think of the experience of watching programs on TV. The model, which may be one object or several objects that interact, would be a particular program, one that does not care what TV set it's being shown on. The view objects display things on the screen and respond to user actions. Pretty much anything you see is a kind of view object. The window, the controls, for example. Your views know how to display information they receive from the model object and how to get any input from the user the model may need. But the view itself should know nothing about the model. You can think of the view as a television screen that doesn't care about what program it is showing or what channel you just selected. The UIKit framework provides many different kinds of views. If the view knows nothing about the model, and the model knows nothing about the view, how do you get data and other notifications to pass from one to the other? To get that conversation started, as in, model, I've just updated my data. View, hey, give me something to display. Well, you need a third element in the MVC design pattern, and that's the controller. Controller objects connect the application's view objects to its model objects. They supply the view objects with what they need to display, which they get from the model, and they also provide the model with user input from the view. You can think of the controller as a circuitry that pulls the show off the cable and then sends it to the screen or requests a particular pay-per-view show. An advantage of using this application model is that it allows you to separate these three parts to your application and work on them separately. You just need to make sure that each group has a well-defined interface. When the time is right, you just connect the parts and you have an application. So imagine that an iPhone user is in San Francisco and he or she starts the weather app. The view will display his or her location as San Francisco. The user may tap a button that requests the weather. The controller interprets the request and tells the model what it needs to do by sending a message to the appropriate method in the model object with the necessary parameters. The model accesses the weather.com website, and the controller then delivers that information to the view, which promptly displays the information. When you think about your app in terms of model, view, and controller objects, the UIKit framework starts to make some sense. It also begins to lift the fog from where at least part of your app-specific behavior needs to go. One way to add behavior is through the model objects in the MVC pattern. Model objects contain the data and logic that, well, make your application happen. Another way to add behavior involves using the delegation pattern, which allows you to customize an object's behavior without subclassing it by basically forcing another object to do the first object's work for it. For example, the delegation design pattern is used at application startup to invoke the application did finish launching with options method, and that gives you a place to do your own app-specific initialization. All you do is add your code to that method. Delegation is a pattern used extensively in the iOS frameworks, such as UIKit and AppKit. It's used to customize the behavior of an object without subclassing. Instead, one object, which is usually a framework object, delegates the task of implementing one of its responsibilities to another object. You're using a behavior-rich object supplied by the framework as is and putting the code for program-specific behavior in a separate delegate object. When a request is made of the framework object, the method of the delegate that implements the program-specific behavior is automatically called. For example, the UI application object handles most of the actual work needed to run the application. But as you see, it sends your application delegate the application did finish launching with options message. And that gives you an opportunity to restore the app's window and view where it was when the user previously left off. You can also use this method to create objects that are unique to your app. When a framework object has been designed to use delegates to implement certain behaviors, the behaviors it requires or gives you the option to implement are defined in a protocol. Protocols define an interface that the delegate object implements. On the iPhone, protocols can be formal or informal, although I concentrate solely on the former because formal protocols include support for things like type checking and runtime checking to see whether an object conforms to the protocol. In a formal protocol, you usually don't have to implement all the methods. Many are declared optional, meaning that you have to implement only the ones relevant to your app. Another way to add behavior is by using block objects. The block object design pattern is similar to delegation, but it's more event-driven in that it allows you to create methods or functions that you can pass to other methods or functions that are executed as needed. For example, you might want to have some code that scrolls the view as necessary when the keyboard appears. You would pass that to a method that is invoked when the keyboard appears. Although delegation is extremely useful, it's not the only way to customize the behavior of a method or function. Blocks are like traditional C functions in that blocks are small, self-contained units of code. They can be passed as arguments of methods and functions, and then used when they're needed to do some work. With iOS 4 and newer versions, a number of methods and functions of the system frameworks are starting to take blocks as parameters, including completion handlers, notification handlers, error handlers, enumeration, view animation and transitions, and sorting. In this case, we're using the animate with duration method to animate the view with a block object. As you'll see, when we develop the animation for our sample app, we will use the block-based animation method animate with duration to animate the view. Yet another way to add behavior involves the target action design pattern. This allows your app to respond to an event. When a user taps a button, for example, you specify what method should be invoked to respond to the button tap. What is interesting about this pattern is that it also requires subclassing, usually a view controller, to add the code to handle the event. You use the target action pattern to let your app know that it should do something. A user may have tapped a button or entered some text, for example, and the app must do something. The control, a button, say, sends a message, the action message, that you specify to the target. The receiving object, or the target, is usually a view controller object. If you wanted to develop an app that could start a car from an iPhone, which is not a bad idea for those who live in places like Boston in the winter, you could display two buttons, Start and Heater. You could use Interface Builder to specify when the user taps Start that the target is the car controller object and that the method to invoke is Ignition. The target action mechanism enables you to create a control object and tell it not only what object you want to handle the event, but also the message to send. For example, if the user touches a ring bell button on the screen, you want to send a ring bell message to the view controller. But if the wave flag button on the same screen is touched, you want to be able to send the wave flag message to the same view controller. If you couldn't specify the message, all buttons would have to send the same message. It would then make the coding more difficult and more complex because you would have to identify which button had sent the message and what to do in response. It would also make changing the interface more work and more error-prone. So when creating your app, you can set a controls, action, and target through Xcode's Interface Builder, as we see in another video. This setting allows you to specify what method in which object should respond to a control without having to write any code. The UIKit framework provides a great deal of ready-made functionality, but the beauty of UIKit lies in the fact that you can customize its behavior using any of these design patterns. One of the challenges facing a new developer is to determine which one to use.